All right, I think we're going to go ahead and get started to try to stay on schedule. I think they're going to bring some more chairs in the back. This is an impressive turnout here. I appreciate all the people standing in the back. So this is Apache NiFi in the Hadoop ecosystem. Quick agenda. So I'm going to try to give a little bit of background on NiFi. Unfortunately, we can't, that'd be a whole presentation to do just an introduction to NiFi. The agenda for this talk is to really focus on how NiFi integrates with the rest of the Hadoop ecosystem, and then talk about a specific use case and how it can fit into the architecture, and then some of the roadmap for Apache NiFi. And kind of my hope is that at the end of this talk, everyone has a better idea of how NiFi can fit into what they're doing, right? I think there's still a lot of confusion with all the technology choices that are out there. When do I use NiFi versus when do I use stream processing versus when do I use Kafka and things like that. So I'm kind of hoping that by the end of this, that's a little bit clearer. And if it's not, let's definitely talk more after. Really quick about me. So I work on the Hortonworks data flow team. I originally joined a company called Anyara, which was started to basically work on NiFi commercially and take it to the commercial world. Started by the original creators of NiFi who came from the government space. And then we were pretty short-lived and quickly got acquired by Hortonworks. And now we're the Hortonworks data flow team. I've been a committer and PMC member on NiFi for about a year. And I tend to work on a lot of the integrations with NiFi and a lot of other systems. So I've worked on like HBase integration, Solar, syslog, a lot of the stream processing integrations, things like that. Okay, so trying to dive into what is Apache NiFi. So I think when people hear the word data flow, they start to think of a simple scenario in their organization like this, where you're acquiring data from some sources, and you want to bring that data back to your analytic platforms and to your data stores, right? Things start off seeming really simple, no big deal. When we start talking about a larger organization, you start to have the same problem in multiple places in your organization, right? All over geographic locations, and things start to get a bit more complicated pretty quickly, and you end up with something more like this, right? You have all over the place different scenarios that all have this data flow problem. You need to share data between these locations. You have different users who can access different locations. There's different security requirements in terms of protecting data certain ways or what users can see certain data. There's different infrastructure, so there might be limited resources at certain locations. You need to move data securely between these locations. And so things get a bit more complicated, and all the challenges of like this picture right here is what NiFi was created to address, right? So the global enterprise data flow problem. So just kind of walking through the key features of NiFi. We're not going to be able to go into every one in super detail, but the idea is to be able to visually build your data flow, right? So we don't want to write code, deploy it, and then when someone asks to change it tomorrow, we have to stop that, write new code, deploy again. We want to be able to change this data flow. We want to see it on the screen. We want to be able to see everything that's happening. We want to know if there's a problem. We want to know how things are working. We want to just react and drag a new connection on and change our data flow. We want to track everything that's happening. So that's the concept of data lineage and provenance. We want to know if we receive a piece of data from somewhere, what did we do to it and where did we send it? If someone comes back to us and says, a compliance scenario, right? Did this data make it to this destination where it wasn't supposed to go? We want to just easily look that up. We don't want to have to go grepping through logs and doing all kinds of things on the command line. Someone whose job it is to just monitor the data flow should be able to respond to a question like that. We want to be able to prioritize data. So in that previous picture where you have data moving across everywhere, there's going to be cases where there's limited bandwidth, and we might have data sets that are higher priority than other data sets, and we need to ensure that we bring back the highest priority data sets before the other ones. We need to be able to buffer data and control back pressure. So back pressure is this idea that if things downstream are not keeping up with the flow of data, we need to be able to slow down what's happening in the data flow. So you can control this in your data flow on the different queues, and things can bubble all the way back to the source and say stop producing data or like pause for a little while things catch up. So there's a lot of controls like this throughout the data flow. You can make decisions about latency versus throughput. So there's a lot of scenarios where you want the lowest latency possible, which means for a specific message, process that as fast as possible and get it to its destination. There's other times where you might be willing to sacrifice a second or two of latency to achieve higher overall throughput. And so those are decisions that the user gets to make in NiFi when they're configuring processors. They can make a trade-off there. We want to take security very seriously. Security has always been like a main priority for NiFi. It's not something we added after the fact. So we want to secure the control plane, the user interface, role-based authorization, things like that. We want secure data transfer between NiFi instances, between NiFi and other systems, between nodes in a NiFi cluster. So there's a lot of aspects of security. We need to be able to scale. So if you get the NiFi distribution, you download it, unzip it, start it. It's pretty easy to start up. You're in standalone mode. You can actually do a lot with a single instance. We want to be able to scale out to a cluster, right? So there's a cluster manager, several data nodes, and you're dividing up your data across your cluster. And we also want the framework to be as extensible as possible. So there's always going to be this last mile problem, no matter how many processors are provided with the distribution. Everyone's always going to have that one problem in their organization that doesn't fit into one of the existing processors. So we want to make it as easy as possible for everyone to build their own processors and add that functionality in there. And the whole way that NiFi itself is built, it uses kind of the same extensible model internally to actually run the framework that it would for anyone who's just building a processor that they want to deploy. So kind of talking about the difference between NiFi and some other technologies. So what are the things that NiFi is used for and good at? Moving data between systems reliably and securely, right? Definitely driving data to your analytic platform. So that's like one of the top use cases is you stand up one of these Hadoop clusters or some analytic platform. Okay, how do I get my data to it? NiFi is a great tool for that. And along the way, you can do a lot of simple things to prepare and enrich your data in NiFi. So generally, we call it like simple event processing, things you can do on one piece of data at a time. Transform a format. Maybe you have JSON and you want to turn it into Avro or something like that. Maybe you have JSON and you need to extract a specific path into your JSON, pull that up to make a decision. Maybe I want to make a routing decision. Every JSON document that has a specific value in this one field, I want to send that to one system, and if it doesn't have that, send it to another system. So these are all the things that NiFi really excels at, doing these enriching, conversion, routing decisions. What it's not really used for is it's not made to be a distributed computation platform. So if you compare the way a NiFi cluster works to something like Storm or another stream processing platform, NiFi doesn't take your graph of processors and break it up and run it on different nodes and then scale those the way Storm would with the bolts. NiFi runs the same graph of processors on every node in the cluster, and it's the data that's being divided up. So it's not really made to be this massive computation platform, right? That's what the stream processing platforms are good at. NiFi is not trying to replace any of those platforms. It's complementary to all those platforms, and it can bring data to those stream processing platforms. And the same thing with complex event processing and joins and complex window operations. Those are not the things that really NiFi is trying to solve. Those are better solved by all those other stream processing platforms. Okay, so I wanted to walk through some of the core integration points in Hadoop and kind of give a little bit of examples of some of them, how you might use them in NiFi. So the most common one is ingesting data to HDFS, right? And a lot of times the scenario is you have a lot of small messages moving through NiFi. You're not going to write all those small messages to HDFS because you don't really write lots of small files there. You want relatively large, or maybe not for today's standards, but larger than kilobyte-sized files. So the way that the pattern you typically do in NiFi to achieve this is you use a merge content processor. This processor can take a whole bunch of incoming messages and, based on configuration, decide when to merge them into a single message. The way you can configure that is either based on the size of all the total size of all the messages, a time setting, and I think even number of messages. So you can sort of choose between all those options and combine them together to get your appropriately sized file coming out. Then what you can do is you can dynamically set the file name and directory of where you want to place that file in HDFS. So if you wanted to do something like bin your data in directories down to the hour or whatever your time range you want to bin by, you can use this NiFi expression language. So right in that update attribute processor, there's a property where you would set a value like that. And while it's running, it's calculating what the current directory would be, dropping it in there, and it'll make that on the fly if it's not there for you. And by the time it gets to put HDFS, most of the heavy work has already been done. And put HDFS is just simply writing the content of that message to HDFS. When you configure put HDFS, you're basically providing the core site and HDFS site files so it knows how to access your Hadoop cluster. So it doesn't have to, sometimes we get asked, like, does it have to be on one of the nodes where, like a data node where Hadoop is running? It doesn't have to be. You just need the configuration so that it knows, obviously, network communication to your cluster. But besides that, it could run on another node. And you'll typically see this pattern where you can reroute a relationship back to itself. So if it hits a failure for something like a network problem writing to HDFS, it'll stay in that failure loop and continue retrying. And there's some other options you can set as to a delay before you retry, because you don't want to just keep retrying, right? So if we look on the flip side, pulling data out of HDFS, it doesn't sound as common, but actually it comes up a lot. So the way this is typically done is with two different processors. There's a list HDFS and fetch HDFS. It'll be a little more clear why it's two pieces in a minute. But the listing one, you would set that to run on some kind of timer. So however frequently you want to pull a directory for new files, and it's keeping track of the last timestamp of the newest file that it's seen. So every time it runs, it's pulling new or modified files. And it can also recurse. So you set a directory and you tell it whether or not you want to recurse into that directory. And then coming out of that processor is a flow file for every file that it found. So all it has is the path in it to a file that needs to be fetched. So if it finds 100 files in a directory, there's 100 flow files coming out to the next processor, and they each have a full path in HDFS. And then fetch is responsible for actually pulling that file out of HDFS. And in the fetch processor, you can set a static file if you wanted to just fetch a static resource over and over, but when you're using them together, you set it to a dynamic expression, and those path and file name are what are coming out of list HDFS. So as it's coming in, it's dynamically evaluating that and saying, okay, this is what I need to fetch, right? The reason why it's broken up into two pieces like that is because if you're in a cluster, what you really want is to be able to fetch in parallel. But you only want to do the listing on one node, because if you don't want all nodes in your cluster to perform the listing, they're going to list the same data, right? So what we do is a NiFi cluster has this concept of a primary node. It really doesn't have much meaning other than you can schedule a processor to only run on the primary node. That's really what it's used for. So we can set list HDFS to run on the primary node. So it'll do our listing. A RPG is a remote process group. That's normally used to communicate between two NiFi clusters. But in this case, we're actually going to just point it back at the same cluster. And what that's going to do is all the results of that listing are going to get redistributed between the two nodes evenly, or as many nodes as there are, right, evenly. And by the time it hits the fetch processor, now every node is fetching in parallel. So this is a common kind of trick or pattern to perform a parallel operation. There's several of these list fetch processors that you could use this pattern on. So there's list file fetch file for regular file system, and there's a list SFTP and fetch SFTP. Okay, so HBase. For HBase, NiFi has this concept of a controller service, and a controller service is like a global resource. You typically use it for something that's like expensive resource, like a connection pool. You could also use it for if there's a lot of configuration that you're going to have to set up in several processors and you don't want to enter the same information a whole bunch of times. You could have a controller service where you enter it once, and then the processors reference that controller service. So for HBase, we actually did it for HBase more to kind of shield the processors from the client that we were using. So we know there's different versions of HBase that people are going to be using. And we don't want the processors to have to change all the time and be stuck on one version. So we have a controller service that sort of abstracts away the HBase client that we're using. And we happen to provide one implementation of that service, which is based on HBase 112. But the point of this is that someone could easily implement the same thing for like HBase 096 or whatever that last 01 that a lot of people are still using. And the configuration for this service, it's similar to the Hadoop processors. You provide your HBase site file and your core site, and then you can optionally specify your Kerberos credentials if you're using a Kerberized cluster. And there's some other settings you can like override if you wanted to reduce, like the HBase client retries a lot of times. If you don't want it to retry 35 times on a failure, you can set that to 1 there. So you would configure this first, like globally, and then there's 2 processors you could use for ingesting data. There's put HBase cell, which is for writing individual cell. This is good if you have some like arbitrary byte payload that you just want to write into, you know exactly where you want to write it. It doesn't really do anything with the content. It just takes bytes and puts them in a cell, right? And you provide the table, row ID, column family, column qualifier, and they can support dynamic expression language. So they can be set like upstream based on other things that happened in the flow, and then it'll evaluate those values at runtime. Most of the time, though, you want to write more than just one cell. So the way you can write a whole bunch of cells to one row is put HBase JSON. So it basically is taking a JSON document and taking all the field value pairs and turning those into like the column qualifier and values, right? And for the row ID, you can either choose between it being one of the fields in the JSON document, where to get the ID from, or it can come from an attribute. There's also, if you think about JSON, you can have nesting in your JSON. So what do you do when one of the fields is a complex nested document? Well, let the user choose through a property. You can either choose to treat that as a failure, so we just won't ingest it if it has a complex field. We could choose to produce a warning, so it would ignore it, but still warn you in the UI. Silently ignore it, or just take like the 2-string representation of that and just stick that in there so you still store something. But basically let the user make this decision as to how to handle that. So Kafka integration, these are pretty self-explanatory processors, but put and get Kafka. So it's a pretty common use case to use NiFi to get data from all these different sources and deliver it to a Kafka topic. A lot of people are already heavily invested in Kafka and doing great things with that. So you can use this as a way to bring data to a Kafka topic. For put Kafka, you provide your broker and topic name. And then you kind of have 2 options. It can either publish a flow file as a single message to the topic, or if you have a really large file that's, say like a huge log file delimited by new lines, NiFi can stream that file in, separating by the delimiter and publishing a message per line. You provide the delimiter as a property in the processor. And then get Kafka, to pull messages in. It's just like a Kafka consumer, right? You provide the Zookeeper connection string and the topic name. So stream processing integration. Just to give some background on, lead up to how the stream processing integrations work, they're all based on the same concept, and it's related to how 2 NiFi instances talk to each other, which we call a site-to-site connection. So in site-to-site, you can have one NiFi instance pull data from another, or one push data to another. And if you think about that, that's similar to how stream processing works, right? Usually every stream processing platform has a component that's like a source component that pulls data from somewhere. So that's very similar to how we have a NiFi instance pulling data. And luckily, someone on our team took that code behind site-to-site, created this nice reusable client called the site-to-site client. It can be used in any Java program. You could easily write a main method in like 10 lines or something that could interact with a NiFi through site-to-site. And that's going to be the foundation for how the stream processing integration works. The benefits to using site-to-site is that it handles a lot of the things for you. So if it's a cluster, it knows about the nodes in the cluster, and it can handle pulling from all of them or sending data to all of them. And it can also provide secure connections using two-way SSL. And so when you're starting out writing this code, you'd create this site-to-site client config, and you'd tell it the URL of either your standalone NiFi or the cluster manager if it's a cluster. And then you tell it a port that you're going to pull from. And a port here is actually a component that you put onto the NiFi graph. So you drag a port on from the toolbar and you name it. So you might say like data for Storm or data for Spark streaming, right? And that's the name that you would put here. And I know everybody's not like Java developers, and looking at code on slides is not always the best, but I just wanted to show these to kind of see how simple the code actually is. You'd create a client using that config. You create a transaction and specify the direction. So in the poll scenario, you're specifying receive. From the transaction, you start calling receive to get these data packets. The data packet is essentially like one flow file from NiFi. So you get, on that data packet, you get access to a byte array, which is the content, and a map, a string map, which is the attributes. Then you can keep pulling data packets, call confirm, which does a checksum to ensure that when the transaction was started, what the NiFi thought should be pulled was actually correctly pulled, and then you complete the transaction. On the reverse side, very similar. You just use the send direction. And the only thing here is you need to have a way to, whatever you're doing in your stream processing platform, you need to have a way to turn that data into a data packet, right? So we kind of have this like interface, NiFi data packet, but it's really up to whoever's creating that stream processing job to figure out how to, provide that data in a NiFi data packet. But you just send back the content and the attributes, and again, confirm and complete the transaction. So using like very similar code to what we just looked at, we have integrations for probably the most popular stream processing platforms. There's a NiFi Spark receiver that is provided in the NiFi code base. So every time NiFi does a release, there's a Maven artifact published that you could use to pull in the NiFi Spark receiver to pull data into Spark streaming. The same thing for a NiFi spout for Storm. For Flink and Apex, it's in their code bases. So in Flink, there's a NiFi source and a NiFi sink. And in Apex, they're called input operators and output operators. So really, they all use that same underlying approach. And then other integration points that maybe people wouldn't consider like the proper Hadoop ecosystem, but definitely related, but we can't go through all of them. There's processors for Solr, Elasticsearch, MongoDB, Cassandra, Couchbase, relational database processors, and Splunk. And then there's pretty much a new processor coming out like every week, somebody from the community submitting a pull request, or someone on our team building one. There's actually surprisingly really good documentation for every processor. It's part of the development lifecycle. When you develop a processor, you provide the documentation directly in the code, and the docs are auto-generated. So it kind of forces you to you can't really deploy a new processor without having documentation. And every processor's docs are listed out there. I go to that page every day to look at how a processor works. So you can just keep checking there for new processors. Okay, so I want to talk about how you could use NiFi in architecture. How would it fit into what you're doing? So I think most people probably think of something like this, where you're bringing data from data sources back to your core data center where your analytic platforms are, where you're doing all your analytics. And if you think about like the original picture from the very beginning, you could imagine that maybe one of those geographic locations was like your core data center, and some of the other ones might be like your regional data centers. And you kind of have this like different aggregation points along the way where you would gather up data in a NiFi instance. Maybe that's like a less powerful instance. It doesn't have to be a cluster maybe. And that might feed back to a cluster, which is then feeding in there, right? So you kind of have this left to right data flow from smaller data sources all the way back, right? I think where it starts to get more interesting, and what we'll probably start seeing more of in the future, is like two-way data flow, bidirectional data flow. So actually take those results of what we're doing, analytics, and be able to push those back out to the edge and do something intelligent with those, right? And NiFi gives you all the tools to do that, right? So we've been talking a lot about bidirectional data flow, but we haven't really had a lot of good examples that we've been able to show. One of my colleagues, Simon Ball, has a really awesome demo that I think you can see at the Hortonworks booth. He's doing. He has a better example than what I'm about to show. But so the example I have, I know this is pretty complicated, but we'll talk through it. So basically, it's not that much of maybe a real world example, but the idea is the same blueprint. You could change whatever the data is and what the analytic is and do the same thing with some other data, right? So for this example, we're basically collecting logs. So we have all these edge NiFi instances collecting logs, and we're feeding them back to a core data center and then providing them to a stream processing platform where we're doing an analytic. And the idea is like, maybe we can't collect all the logs initially because there's too many, right? And we don't have the bandwidth and the resources. So we'll start out by filtering to only get error and warning messages. And think of just like your Java logs that every log line has a level. So we'll look for the errors first. But when they get sent back to the analytic, if the analytic determines that over some time window, we haven't really received that many errors and warnings, well then why don't we tell the edge to start collecting more logs, because we can handle it until things start flooding in, and then we'll slow down again. So we'll create this complete loop that just keeps adjusting itself based on what's happening. So going across the top, logs going in, the analytic result is basically determining what are the log levels we should collect. It's either saying do the same thing, just collect errors, or here's a new set of levels to collect, and it keeps going back and forth. When it gets those results back, it stores them like somewhere on disk, wherever you want. And one of the cool things you can do in NiFi is you could build a web service embedded into your flow by just like dragging and dropping processors. When people see this, it usually is like they can't believe what happened. But you literally just drag a bunch of processors. We'll look at the actual flow in a minute, but the one processor is actually running an embedded Jetty inside of it and exposing context paths. So it's pretty cool. And then we can have the edge be polling that web service, every so often, saying like, what are your latest results? And when it pulls them in, it'll automatically update these filters and just start, filtering based on the latest results. So we'll talk through how this could look in NiFi. So this could be like one of the flow on the edge instance. There's a tail file processor. You point it at a log file, and it'll tail that file, and it handles like when it rolls and everything like that. And it's basically grabbing new lines that are being written to that file. So because it can grab multiple lines, we want to get each line by itself. So there's a processor called split text, which you can set the line count to 1, and you can set a delimiter of new line. So it'll basically take a whole bunch of lines coming in, split them, so now we have 1 line per output. And then for each of those lines, we want to figure out what level is this, right? Is it an error message? So we can apply a regular expression in the extract text processor, which can identify what's the log level and pull that up into an attribute. And then we want to filter. So the scan attribute, you tell it in a file of inputs that you're interested in, and as new flow files come in, it scans their attributes against your values of interest, and if there's a match, it lets it through. If there's not, then it routes it to like a failure or just like an unmatched relationship. So the file that scan attribute is pointing at, that's basically what we want to keep updating, right? That's like our set of filters that we're interested in. So when we pull the core instance and we say, what are your latest filters you have? What we're going to do is take the results of that and store it to a file. That's going to be the file that scan attribute is looking at. And this is going to be running on a timer, however frequently you want to look for new results. And then that box over on the right, that's a remote process group. So that's representing a direct connection back to the central NiFi. So this is what, you could imagine this running on like 100 edge nodes or something like that. Tailing logs on servers. Today you could run NiFi on something as small as a Raspberry Pi. Actually the demo at the booth, that's what they're doing. So you could be imagining picking up log files on a Raspberry Pi and shipping them back to a cluster of 3 nodes or something like that. So in the core NiFi, there's kind of 3 parts to the flow. The top part would just be where the logs are coming in. So that's an input port where the logs will be coming from the edge node, going straight across to logs for analysis, which that's where you would latch on a stream processing platform, whatever one is your favorite. When the stream processing platform produces its results, it would write it back to this middle part. So there's a new results coming in, it writes it to a file, and down here is where we build a web service. So this handle HTTP request, that's the processor that exposes a web service. And when that request comes into this path, dictionary is just a term in NiFi, so don't read into that. But When it comes into that path, it'll go fetch that results file and then respond all the way back to the caller. So that's how you can do some really, you could basically create a REST service to front almost anything. Like if you wanted to create a REST service in front of a Kafka topic, you just put that processor in NiFi and then use one of the Kafka processors, and you're automatically able to just post data to Kafka. So you can do pretty cool things like that. So just kind of in summary, we're just creating this full feedback loop, right? So logs going left to right, analytic results going back, and adjusting what's happening on the edge. And I think this kind of like bidirectional thing is what we're going to start seeing a lot more. And especially when you start considering like IoT and all these small devices and sensors, it may not even be like a core data center, right? It might just be a lot of back and forth communication amongst a whole bunch of smaller NiFi instances. So talking about roadmap and some future work. So these are more not necessarily work that's going to be done in NiFi, but just I figured of interest to probably the people in the audience is other integrations specifically with HTTP and things like that. So there will definitely be, we know people want Embari support to be able to install NiFi. That will definitely come. There will be an option to do authorization through Ranger. So right now, NiFi will always have its own ability to do authorization because NiFi always has to be able to run somewhere where Hadoop is not, right? So it's never going to be dependent on any of the technologies in Hadoop because it has to run in places where it won't be. But there'll be an option for if you are co-located with Ranger to use that for authorization. And in terms of governance and lineage, so Atlas is an interesting project that is doing a lot of things around lineage, more at like the metadata level. NiFi does some provenance stuff more at the data level, so tracking what happens to each event. But there's potentially some interesting integrations there between NiFi being in the position where it is, it knows where data is coming from, and sort of creating this full link through your enterprise of like knowing that this NiFi instance delivered data to this HDFS instance and having that full traceability, right? So there's a lot of things here to be designed, and I'm providing no timelines, but these are things that will come. Specifically for the NiFi roadmap, so things that the community is already working on a lot of these or has already designed a lot of these. We know that the high availability is an important thing for both the control and data plane. So right now, the cluster manager, if it goes down, that's like the single point where you access the UI. So we're going to be moving to an approach where you can access the UI on any node, and you won't have to go to a specific manager node. In terms of the data plane, we'll be able to replicate data on a node to another node. It turns out that that's not as much of a problem as people initially think because, I mean, first of all, data is pretty short-lived in NiFi, right? It's just moving through it to its destination. We're not holding on to it for long periods of time. Obviously, that node could go down, and there could be data in there temporarily until you bring it back up. You can also do RAID configuration on your disk. If the most common scenario is that disk fails, you can easily prevent that. So it's not as big a deal, but it's definitely important. Multi-tenancy, so we know that there's organizations who want to use NiFi, different groups using the same NiFi instance, and they might not all have the same permissions. They might not want one group to see what the other group is doing. Today, security is done more at like a global flow level. So you have a role when you go into NiFi, and that controls what you can do. But if you have like a role that can modify the flow, you could do that for anything in the flow. You can't restrict parts of the flow. So we'll be moving to an approach where someone might not even be able to see the things that are on the flow from another group, but they'll all be running in the same instance. Extension registry. So because of the way NiFi deploys processors in these NAR bundles, it creates a pretty large distribution because we do class loader isolation to avoid conflicts between different processors. And that creates a pretty large distribution. And in reality, a lot of those processors don't need to be part of the actual like NiFi release process. They could be things that are just added on after the fact. So we want to pull out and get to more of like a plug-in model where a lot of those processors are in some kind of central repository, and you'd get a pretty small distribution. You'd start it up, and then you'd pick and choose and say like, okay, I want to add the Hadoop processors, I want to add MongoDB, whatever you need. And we also want to put templates into that registry to be able to share examples. Templates is a way to kind of like take a portion of your flow and export it and send it to someone else, and then they just import it into theirs, and they can see exactly what you were doing. It's a great way for learning. There's a set of, Hortonworks has a GitHub repo with 50 or something templates that show how to use a lot of the common processors. Variable registry. So we know there's some work that needs to be done to kind of improve the scenario where people want to, so like, let me back up. Where NiFi came from, a lot of the approach was not to really have this standard life cycle where you have like dev, integration, production. It was kind of like you're building your flow in real time and you're changing it all the time. So you're not gonna take like this copy of your flow and then deploy it somewhere, because that kind of defeats the purpose of being able to change it all the time. But in reality, that is the way a lot of organizations work. And so we need to handle that better, and there's a lot of improvements. One of them is this variable registry idea, which is to be able to, for properties that are going to be environment specific, so all of those like connection strings or things like that, passwords, usernames and passwords, those should be defined outside of the processors in some kind of variable list, but directly through the UI. You can do something like this today, but you have to manually edit config files. So we define that outside and make the flow more portable. There's going to be more things done, but that's one of them. We want to take a fresh look at the user interface. Even though NiFi is kind of a relatively new open source project, it's actually been in development for a really long time at the government. So for a lot of the UI, it's been around for a pretty long time, and there's a lot of more modern things that could be done. So just do some redesign. That'll also help with the multi-tenancy work that we were just talking about, because there's a lot of changes to the UI that have to happen to do that multi-tenancy stuff. There'll continue to be new integration points all the time. I know there's some work being done on Hive processors. There'll always be more. And then there's a very, very new concept that is just happening in Apache land right now. It's called NiFi, so it's a sub-project of NiFi. And the idea is that, so as I said before, you could run today's NiFi on a Raspberry Pi, but you need a JVM, and your minimum memory footprint is like 512 megs of RAM. And you really also, before running on the Raspberry Pi, need to kind of strip out a lot of the extensions, because it takes a really long time to start up with all the processor it needs to load. And really on the Raspberry Pi, you're not going to be using like hundreds of processors. You're just going to need a couple. So we know that NiFi needs to run on smaller and smaller things. It needs to be able to run where there's not a JVM, so native environments. So NiFi is going to be the project to tackle that, right? So it'll be a small, super small complementary data agent that can connect natively up to NiFi. It'll help, or it will be able to keep that provenance trail of data between the agent and NiFi, things like that. So it's like brand new, just got voted on to have an official sub-project in NiFi. Yeah, and that's pretty much all I had. I don't know how much time we have, but I'm sure there's some questions.
Hi, just try to set boundaries because of the first slide you had with what is NiFi for and what is not for. To try to set boundaries between the NiFi and the Storm. Because with Storm we basically create a graph of flow of processing, but basically you're also creating the flow of data flow, right? So some basic and standard example would be Kafka spout with Kafka bolt and HBase bolt. Are you suggesting actually that we remove spouts and bolts that are for data flows in and out and put NiFi in between of the Kafka and HBase and Storm, or you see somehow different?
Yeah, so the question is around if you're using Storm more for data flow rather than like a distributed computation type of thing. Am I suggesting using NiFi for that? So I'm not in any way knocking Storm or Kafka, right? If you're doing that successfully with those already, the scenario was if you were reading data off Kafka and then using a bolt to write it to HBase. If you're already doing that, it's working. I'm not saying go replace it, right? If you were starting a new project and needed to do that, you could do that super easy in NiFi without using those technologies. I think before NiFi came along, there really wasn't another choice to do what you're describing. So there were a lot of simple Storm topologies that weren't really using all like the parallelism and things that Storm provides. They were just doing like a spout and then maybe like 1 or 2 bolts that were in like a straight line, right? And that's the kind of thing that you can do pretty easily in NiFi. So, but I think there will be a lot of complementary use cases, right, where you use all those technologies together.
Could NiFi replace reliable message queue?
Could NiFi replace reliable message queue? All right, time's up. We can chat right here. Thanks for coming, everybody.